Welcome to CW 2.6. Today we're going to review even and odd functions. So you covered it a long time ago, so we're just going to review it. What you want to write down is this. F of x equals f of negative x. This is the algebraic definition for an even function. Even meaning it has y-axis symmetry. Underneath you're going to write equals negative f of x. If these two are equal, that's going to be an odd function, and that's going to be origin symmetry. So I'm going to do 3 examples for you. These bottom 3 you can try on your own if you feel you need to, but let's start with these 3 right here. Determine whether it's even, odd, or neither. So to do this, you just got to show the work properly. What you do is you start by finding f of negative x. So f of negative x is equal to, plug it in, f of negative x, that's equal to negative x cubed plus 6x. So at this point, what you do is you compare it to the original. Notice how these are not the same thing. So that would mean it's actually not even. From there, we check if it's odd. To check if it's odd, you find negative f of x. Negative f of x. So negate the original. Negative x cubed plus 6x. And what you do is you compare f of negative x to negative f of x, the thing you found earlier. Notice how these are equal. F of negative x equals negative f of x. Therefore, f of x is odd, and there's origin symmetry. That's it. So that's the whole process. Now I'm going to show you a couple of things to expedite it a little bit. We're going to write even, odd, neither. The leading degree actually is very helpful. So you see how this is a 3? That actually tells you it couldn't be even. Because at that point, if there's a 3 up front, this number has to be even in order for it to even be considered even. So for this one, notice how there's a 4. That means we actually know it can't be odd, so we don't even check that one. We're just going to check if it's even first. So let's check if it's even. We find f of negative x. We plug in negative x here. F of negative x, that is x to the 4th minus 2x squared. Now compare it to the original, and they are the same. Oh, and actually I should be more precise. This is a g, so we'll put a g right there. We're going to write g of x is equal to g of negative x. Therefore, g of x is even. And this is going to have y-axis symmetry. Now for the last part, we'll write our even, odd, neither here. Notice how there's a 2 here, which means at that point we know it can't be odd. So let's just check if it's even. H of negative x, that's equal to negative x squared plus 2 times negative x plus 1. H of negative x, that would be x squared minus 2x plus 1. Let's compare it to the original. It's not the same. So we're going to write h of negative x is not equal to h of x. And we also know that h of negative x is not equal to negative h of x from earlier, because we know it can't be odd. So we're going to write, therefore, h of x is neither. There is no symmetry. Okay, so that's how we're going to approach those. These bottom three, you can try on your own if you need the practice. I'll put the answer here. This one is even, so that would mean it has y-axis symmetry. This one is odd, so it's origin, symmetry. And this one is neither, so it has no symmetry. Now let's go to our last example. Prove that an odd function times an odd function is an even function. So to start, we're going to write let f of x and g of x be odd functions. So we're just going to state what we know. F and g are two functions that are odd. We're going to start with what we normally do. We're going to find f of negative x, g of negative x. And it's the product. So I can just put these two together, and we're thinking of this as a whole function. So that's where we're starting. Now we're going to think about what it means to be an odd function. If it's an odd function, that means these negatives can be taken out. So I can write negative f of x times negative g of x. And if the negatives are out, that means they will cancel out. Now look at what we just did. We just proved that f of negative x times g of negative x is f of x, g of x. And that is the definition of even. Therefore, the function f of x, g of x is even. And you've proved it.